thank you everyone very much for coming here. It's actually my first time presenting at Pycon. I used to attend conferences before and I used to listen to speakers, so I'm grateful that today I have a chance to share something I learned with you. I'll try to make the talk a bit more like beginner friendly, so everybody could listen. But if you would have some questions or want to dig in some details, feel free to ask those questions at the end. We'll have a few minutes and we can discuss everything that's of interest for you. So my name is Monika Venčkauskaitė. I've actually coded with Python for about 10 years. At first it was a bit on and off relationship, but during previous years it became my main language, largely due to the fact that it's the primary language used for machine learning. So I used to use Python for data analytics for certain data. I looked for Higgs boson. I also use Python for create stable APIs. And one of the greatest actually use of FastAPI is serving machine learning models, which I would like to share with you today. Currently, I'm freelancing actually, so I'm working with machine learning implementations, including ChatGPT. So this field is very fast and very rapidly evolving, and machine learning operations are actually changing there too. So yeah, that would be me. So let's start. What is machine learning operations? It's during the past few years, machine learning models became more and more frequently used. And the problem we experience is how to find the best way to train and to share them and to make them reliable, to make them iterable so we could improve them over time. And solving these problems, we discovered a few methods, a few processes of the way we should organize workflows with machine learning models. And that's how machine learning operations then was born. So, starting from the basics, first of all, when you want to create a machine learning model, the first phase of model creation is its design. So you have to be really logical, a bit scientific, to make right hypotheses, to get the right requirements. And the first design phase also discovers the use cases for machine learning, and the machine learning engineer has to find the right data, also to prepare the data. MLOps processes involve actually quite a few teams in an organization. It might seem like, okay, I can train machine learning models myself, what's the big deal? But to be honest, big organizations have loads of data which is rarely clean. Somebody has to clean it, so we have a data engineering team. Data engineering team uses some warehouse. Data engineers might produce features, then we would have a feature store, and these features will be used only then by machine learning engineers. So you notice that up until this point, until the starting of creating of machine learning model, we already involved a couple of more teams, meaning data engineering and data warehouse. So yeah, in model development phase, machine learning engineer actually works most of the time by himself or herself, and at the end they should assure us that the model is performing the task we intended it to do it. So we need to perform model testing and validation. Also, model has to pass some quality requirements. And then working in a big organization, these things can get out of hand pretty quickly because you have multiple machine learning engineers doing things their own way. And in order to ensure the reliability and the quality of models, machine learning operations engineers have to intervene here. So machine learning operation engineers are responsible for the whole machine learning model training and training pipeline, also of sharing models. And before sharing, we must ensure the quality, we must test your models. And nevertheless, it seems like, well, at this model development stage, we already involve machine learning operations engineer. But the story is not over. Like, one model is deployed and then it's in operation. Very often it's real-time models, which must serve customers in the matter of milliseconds. We must ensure that models are available for all the customer load we are going to experience. Also, that they are not degrading, because many things can happen for machine learning model. They can start losing quality. The data can change, for example. The season has changed, and for example, in the summer, we no longer borrowing codes. So machine learning model has to be adequate and adapt to that. So if we have customers who wanted to shop our store, we would recommend them already clothing by the season. And so on. Like, models can degrade, the user habits can change. We have to be aware of that, track that, and be always present for user load. Because it might change and we might need to give more like throughput for a model. So talking about that, like machine learning operations field has been evolving. There are so many tools you can use to train, serve, and deploy models. One of the few like most known are like Kubeflow, TensorFlow, MLflow, which already have their serving components integrated. Also, you would find something like that on any cloud provider, on Amazon or Google Cloud. But the problem is, like, as soon as we start using these frameworks, we already lose some power to configure things, to make them the way we want them to be. And in this case, if you like want to serve your models and have some custom logging, some measure some parameters, some machine learning model qualities, at this point, I strongly recommend you to use your own component. Many companies, including company I worked before, Vinted, we decided to go with our own serving component to be able to customize it the way we wanted, the way we needed. Okay, so question is, should I go and write my own API for serving machine learning models? If you can foresee, like in your company strategy or in your product strategy, that you will need something that the cloud provider doesn't give you, you should consider writing it. Yes, so where does this API sit in the schema? So you see we will have some API for sharing model. Training will be done before that, like training will be run, the model will be stored in the artifact store, and we'll be running an API to serve a model for the user, which could query the model and get responses. So a very good question, what should I use, Flask or FastAPI? How many of you have used Flask? Oh, that's like many people in the audience. And FastAPI, a bit less, like a bit like half of the amount of people who use Flask. And Django, about that amount as FastAPI. Okay. So it's lovely to know, like, Flask is still dominating the area. It's still the most popular framework. But FastAPI has been growing recently, and there are reasons for it. I hope like the ones who have not tried FastAPI will try it today. I'll try to show you its advantages over Flask. So Flask is a bit of older library. It was released in 2010. But anyways, it's used by the tech giants such as Netflix, Reddit, Lyft, and Zalando. It has a development server included. It's a light framework. You can use Jinja 2 templates to serve something. You can also have extensions to expand its functionalities, and it has integrated support for unit testing. So in its essence, Flask is already a pretty convenient framework, but it requires a lot more like attention. It's more configurable on one side of things, but on the other side of things, it's like the coder is more prone to leave bugs, and also you need more time to prepare your API. And why Netflix chose Flask API? They chose it so they could implement the microservices. It's super configurable. So Flask is more of more transformative than FastAPI. FastAPI is more like has more standardized way of implementing things. And yeah, what's the difference? So FastAPI was released in 2018. It was by Microsoft and Uber. It has excellent performance. It's faster. It supports concurrency, so you can write your asynchronous calls. It has built-in documentation, which uses a formerly known Swagger. Now, currently, it's called Open API Standard. So you guys who worked with a Flask, you know that you had to write the Swagger documentation. You had to implement all the details regarding the request, and including the model, also the error handling. And well, you write this code usually once, so might not seem that terrible, but when you're serving machine learning models, there is a bit of variety in the request bodies we are handling, meaning that each model has its own data structure, and each time when we use Flask, each time when we serve a new model, we should also revisit whether we are doing the right validation and error handling. And with FastAPI is pretty much out of the box. And I hope I'll convince you to try it out with how little code you need to write to already be serving FastAPI models. So, FastAPI versus Flask, battle of the best. Why you should pick FastAPI? So, this is an example code. I will provide you later the link to the repo. You could also read it there. Our goal today is to set a PyTorch model used for image recognition. It's a model by OpenAI, a clip model which you can find pre-trained in PyTorch library. And our goal is to set this model with FastAPI. So I keep the lines who related to FastAPI in bold, so you will see how little I need just to get started. So first of all, I just imported FastAPI, imported some file objects, and then I defined the FastAPI app. It's very similar to Flask at this point. Then I'll have some model functions. We don't have to go in depth at this moment, but you just need to understand that this will be the model to get. This is a function of getting class names from the stored file. So the way machine learning model was implemented, it had a model which gives output as a tensor with certain numbers, and using the classes file, you can look up which class was in the prediction. So yeah, you just load the classes file. Also, I didn't mention, we load the model from Torch library. Yes, now we're getting the classifier. Classifier was stored inside a pictorial file. You just load it. After getting classifier, we need one more function. We need to get features, because the way clip model is implemented, it simply transforms an image from its original form into certain tensor of features. So what we'll be getting out of clip model is only features. So the good thing is, you can train it at this point, you get those features from the image, and then you can simply use something like linear regression to classify in the way you want. In this case, I picked a food data set. I think we will get, we'll see later. But you can just train it on any data set on you want in a matter of hours on your laptop. So clip model is super convenient because the heavy lifting was done by OpenAI before for you. Yeah, so we also describe our predict function, which gets features, uses a classifier to predict those features. And up until this point, we didn't write any FastAPI code, so the only code we're writing here is at post predict. So we're describing a prediction endpoint, which will be accepting a file, and rest is just our code of handling this content. So we read the file, we open the image, we make a prediction, and then we return the class name or error. So you see that I only wrote a couple of lines of FastAPI code, and I already can serve my model. So FastAPI is using Unicorn, so at this point we simply serve right in the terminal Unicorn server ML. It's the name of the file. I described my API, double dots app, and I have reload, so it would reload the server each time I have changes in this folder. So you see, it's super quick to develop, and the things I'm already getting out of this, I already have a documentation. And here's my prediction endpoint. If I test it, you see I already have a button to upload a file. I can execute and get prediction. So here, my model gave a response of cupcakes. So possibly something sweet was in the picture. And so you have all the curl request picture, you have URL, you have some information about the response. And it was a successful response, but nevertheless, what if we would get something that does not fit our schema, which is already inferred from the file we implemented, inside the endpoint. So you would see I would already get an error of this type. So the hard work was already done by FastAPI and Open API standards for you, so you will not need to describe all those errors, which is great, I think. And here you go. You have some default schemas, so you would have errors in this format. So first of all, it's request body. Then there is validation errors, and you can also modify them. But out of the box, they are super convenient. I never actually had to do that myself. So the marriage of FastAPI paradigm is a great thing. It's aided not only like in faster development, but also like in a more transparent way of looking at your request. And it's great to have this kind of startup, because if you have many use cases in your company, you already have a standard way of developing things. Yes, so like using FastAPI Python, there's more. You could define your custom models. Here is a custom user class based model, which defines username, password, and email. And you could already have this response model, a user, which you wrote yourself. So you will never run out of options while using FastAPI. Yeah, so what FastAPI changed for us in our ML ops? So first of all, we got faster response times, faster development. We don't need to implement customer handling or documentation. Also, we have request validation, and it can handle nested JSON pretty well out of the box. So no need to write all this ourselves. So to summarize, FastAPI is asynchronous. So it already can handle concurrency and async requests for you. This is why it's better than Fast. It has documentation included, the data verification included, lower development cost. I would say I agree to that, because the less code you need to write, the faster you are, and it's easy to use. Only like two disadvantages. It has a smaller community, but it's growing. So I already noticed like half of you who use Flask already use FastAPI, which is great news. And yeah, it's a bit less flexible. So in certain cases where you need like to stay very flexible and to be able to configure your APIs to the details, you might want to choose Flask, and it's sometimes these cases sometimes dualize in microservices. But other than that, like FastAPI is doing everything faster, and it's fun to work with it because it's less code to write. Yeah, so thank you for listening. Here is a link to the GitHub repository with the code I presented. You can also contact me if you want to discuss a little bit more. And I'm grateful that I had a chance to talk to you guys. And I would like to hear your questions.
One fast question. No questions?
I have a question.
Yes.
When would you supposed to use RPS rather than REST? What are the use cases to use one or the other?
RPS.
Yeah, the protocol.
It depends on what you want to achieve. I mean, so far I already worked with REST APIs, and I covered machine learning, I covered web apps, and I mean it should be some use cases maybe regarding the data handling, but I mean, I have not encountered myself a situation where REST will not be sufficient for me. I also like work with data streams, then I needed WebSockets, but other than that, just REST was good old enough.